Hey guys, can you hear me okay? Just checking audio.
Yes.
Okay, good. Good to see that. Good to hear. Okay, let me project my screen. Here we go, sharing my screen right now. And a crazy news of the day that I had just now is my car is also a boat. I did not know that. Here, drives through a flooded tunnel out the other side. This is crazy.
Yeah.
And
Where's that at?
I know. And so that happened, and then the car actually is also a boat. When I should take my car into the Lake Sammamish or something, I don't think so. I don't think so. That's what I just saw this news, which is amazing. Okay, cool. So, excuse me. Let us get to what we were discussing last time and proceed forward. So I'm opening up my virtual machine and let us recap what we have covered up until now. And today we will do a couple of intense exercises, which can be a little bit, I should warn, extreme, I would say. That's the right way to put it. It can be intense, it can be extreme, but that's one of the exercises we have for today, which is this one, module number 17. As I said briefly last time, it can be extreme. For those of us who are new to what we have been dealing with up until now, if you have some experience in the past, it's not that big a deal, but yeah, just watch carefully and I should be okay. It'll turn out okay. I want you to succeed in doing all that. I want you to actually succeed in deploying your own platform. That's my goal. So with that understanding, I'm just quickly checking who is still expected. We have only 4 people right now, which is strange. Where is everybody else? So we have Srinivas, Dick, and Tosin. That's it? Huh. That is strange. Okay. We'll wait for a few minutes for them to join and then we'll start getting into the discussion that I want to have. I know many of you have actually completed that Heroku exercise already, which is beautiful. As you may remember or recall, the exercise in Heroku was, let me also grab a piece of paper and pencil. And in that, I will open up a new page and start writing my thoughts. I can see Srinivas there. Hi, Srinivas. And he just stopped his camera, but no worries. So in the exercise that some of you have done already, what you have done is used this company's solution, which is a platform as a service available out there. And like this, there are many other platform providers, as you already know. Red Hat has one big one called OpenShift. And there are many more, like, I think there's a good one also called, what's the call? It is Engineered. I think the name is Engineered. Let me open it up so you will know what I'm talking about. Engineered. This is also a very good platform as a service available for all of us to use. And some services are free. There are supported technologies and supported stacks, Ruby, PHP, Node, Nginx, a bunch of other things. And that is also available as a free trial if you want to try. That's one. Heroku you already tried. And Apprenda we mentioned a while ago. I think it is being used in some companies. It's a closed platform. It is not open source, by the way. And these companies are also proprietary services. However, there are some open source platform solutions available these days, open source PaaS. Let us search who these guys are. And so there are several new but established open source platforms such as, okay, come on, open it up. So OpenShift is one of them. We have Days, and I'll write down. The site is not opening, so I'll write the names. So there are some open source variations of open source iterations of platform as a service. And one of them is Cloud Foundry. I think I'm projecting my screen. I will just double check. Am I projecting my screen? I am. Okay. So Cloud Foundry is one platform as a service backed by EMC Corporation in the division called Pivotal. That's the division. Then another one is we want to use today is this Days platform as a service. We have FLYNN is another one, and there are several more. In fact, if you wait for this article to open, which doesn't want to open, let us do another search. Flynn, Days, and Cloud Foundry. Let us see what we find. Docker is another one, which is driving. Basically, underlying thing is that these guys who are Days, Flynn, Suru, Dawn, Octohost, several other platform as a service initiatives like Cloud Foundry and OpenShift have come up, and many of them are nicely established. This thing that I have been talking about all day long, which is this Days platform, is actually backed by people who run Engineered. I think that's the team, but I'll just find out if that is actually correct. I think it is Engineered people that are behind this open source product. And so you can go to that open source and just find out who the people are, like this guy, and let's find out which company he works for. And looks like he is with Engineered. So he's one of the lead developers of this Days platform that we want to use today. That platform as a service, basically it is your own platform, and your rules. You decide what works, you decide what should work, what is allowed, what is not allowed, and you run it on your own infrastructure. So you get to choose where you want to run it. So these open source solutions are flexible. They give you freedom, right? Freedom meaning it comes with responsibility. For example, it'll put the responsibility on you to make sure that your infrastructure as a service thing works correctly. And then on top, you put your own platform. This is going to be your installation, and that becomes your own PaaS. Whereas if it is run by somebody like Heroku, which by the way runs on top of Amazon Web Services, EC2, as the underlying infrastructure as a platform, infrastructure as a service. And that's what these guys do. They run their own platform as a service. They will give you what is known as a dyno. And a dyno is $33. The last time I checked the price per month. The price may have gone down a little bit, but roughly it is this price. There may be a lower price, I think. But this dyno, if it is used all the time, then that is the price. They also have a concept of a free dyno, which is what I think most of you used. And that free dyno runs about 18 hours out of every 24 hours. And then it sleeps for 6-hour sleep. And that is free for development, for learning, for practice. And that's what this company does. They give you a platform and you run it. They run it. You don't have to run it. They run it on top of this Amazon infrastructure. And by the way, Heroku is a company owned by Salesforce.com. So Salesforce.com, the company that is a company well known for CRM or other solutions, they own Heroku. And if you go look at Heroku, you will find that it runs, the platform itself supports a bunch of languages and bunch of platforms for you to run your applications on. So if you see what is supported, let me just log in. That will give me a better insight. So I logged in, and I'm looking at the upcoming dashboard that I will see, and it tells me that I can, when I create an app, so I say new app, create a new app. It lets me give it a name. I create an app, and when I create the app, it will then ask me to choose how I want to add my application. And so literally what I have to really do is create my app, put that in a Git repository, and then give it to Heroku. That's all I need to do, and Heroku will run it for me. They will also scale it for me if I pay them money. If I pay them money, they will gladly scale it. So what does that mean? It means let me erase the lines here. So if I am paying them money and I'm getting some traffic from these people who are going to hit my site, and lots of people try to visit my service that I want to run here, what will happen as a consequence is that this one dyno that I might have will get automatically scaled out like this. More dynos will appear based on how much load these customers are putting on top of my application that I want to run here. So more people, so you get more people, you get more dynos added on, automatically it scales out. And when people go away and not much load, it scales back down. And that thing happens by itself. And then you don't have to pay for the nodes that go away. And that scaling operation is also done for you. So the core idea is, excuse me, let me get back to that writing. So the core idea is that it is scaling. It helps you run, it helps you scale. It will deal with problems, maintenance, updates, patches, infrastructure management. All of that is done for you. And you just pay them $33 per month for dyno.
I know you were coming.
And then everything works. That's the scenario, usage scenario. This may be nice for some companies that don't want to deal with this infrastructure problem or scaling problem. They just want a scalable solution, and they are willing to give them this money. That becomes a very, very decent solution, by the way. So if that is the case, it may be a good idea to just evaluate ready-made platforms like Heroku or OpenShift or Engineered or Apprenda or you name it, and just use those. And that's a valid way of dealing with creating your app and just giving it to the company. They'll run it for you. That's what most of you, I think we started doing that Heroku exercise. I know many of you actually succeeded. Like here is Salam's example. Oh, he deleted it. Looks like he deleted, but no worries. The idea is that the idea essentially is you can deploy your app with ease as long as you're ready to pay them this money, which I think 3 or 4 of you guys have actually completed that Heroku exercise, which is absolutely stellar. Beautiful. Thank you. I didn't even prompt anybody, and all of you, without my help, were successfully actually deployed your own Heroku instance, running your own example application like you have seen, some of you. Let's see if I can find one more example from somebody whose instance is probably live. Let us see if I can find them.
Hello?
Yes.
Okay, I didn't shut it off. I'm going to send you the link, so that way I'm going to post it in.
Okay, paste it in the group, and that will open up for everybody. So we should be able to play with it. And the scenario essentially is you take your app, you give it to them, and they run it for you. That's it.
Okay.
So when you want to change something in your app, you make a change, you save that change, then you do a git add, git commit, and then you do git push, and your push goes to Heroku, for example, Heroku, and you send your master branch to them, and that's the end of story. And it deploys for you right there, and it goes live, like what Salam is going to send us. So here we go. So this is Salam's example, and he has modified the application itself, and the app shows you the current time. That's a simple deployment of an example app. And you can keep iterating as you improve upon or change something or make a feature addition. You make changes to your app, you save, you add, you commit, you push, you're done. That's the beauty of running and using a ready-made platform. Beautiful. Now, the next thing I want to actually discuss before we switch, is there any question on the Heroku thing that you may want to ask in terms of usage or any clarification you need? Please do that, because we will change topics and we will actually discuss a little bit of Docker and then jump into running our own Docker-based platform as a service using this package, open source. And we will put that on some infrastructure as a service. We'll use some other services like DNS, for example. And then we will have our own platform as a service running on top of our own infrastructure as a service. And then we'll create an app and then put that app here and see it live. We'll scale it. And this platform will scale it for us. That exercise is a little bit involved. So we need to understand the days, but before that, we want to understand Docker. But before we switch topics into this Docker discussion, I want to ask you about Heroku. Is there any question or any clarification now, later? All of it is fine. But if there's something you want to ask right now, go ahead. Okay, Tosin just sent her link. And so as you can see, this is Tosin's example. She has very nicely captured this summary of what platform as a service does, which is, you know what, take my code, run it for me. I don't care how you run it. That's the sense, the summary is that, here's my code, take it and deal with it. Scale it up, scale it out, scale it back in, depending on how the customer traffic is. And I will pay you money, but then that's it. I will not do anything else. And that's the scenario of this. in the example that I have in my dashboard, I have tons of examples actually running right now. I'll go to one of those, for example, this app. And here you can see that this is a live app, by the way. And so it was deployed 3 years ago. That you can see that it has been deployed 73 times. And you can configure dynos. I pay nothing for it right now, but it has been running for the last 3 years, no problem. And recently it has been stopped running for every 18 hours it runs and then stops for 6 because I haven't actually paid them money, which is okay. We can deal with it. It is something that we can live with. So we are not spending money unnecessarily. However, I can modify it. I can change my resources and add some, or maybe change the way I use and scale the dynos in terms of how many I want to add, so that it actually scales out. So we can adjust the performance of that app. This one that runs on that particular location, which happens to be, let me see what location is that. I think this app runs on this site, which is running, it seems, right now. So this app is the one that is running. But the point is, you can run your app and deploy it on some platform as and when you like, any number of times you like, and it will help you scale out, scale back in. That's the key summary. Just like what you guys have done already. Here is Muhammad's app, Salam's app, and here is Tosin's. And we have a few more examples that I am not putting up, but they all basically look the same. Okay. Any questions before we change topics, change a core concept that I want to discuss, which is containerization versus virtualization, which is basically the essence of Docker. And then we will do the days exercise. And so I'm assuming that there is no question, which is kind of amazing because you apparently understood the whole thing. That is awesome. So switch topics. Now we will first discuss briefly what virtualization is, and then compare it with what containerization is. So two things. virtualization. And the other idea is containerization. The difference in the two, is it new or understood or seen before, heard of it before? Are these two words familiar to you? Have you played with this question mark? Do you understand it? So I can just adjust the level of depth I want to go. If you know it already, I can go straight to the deeper segments that I want to maybe illustrate some points. If you do not know, I'll take a step back. So give me a thumbs up, yes or no. You know containerization, yes or no? Do you know this? I suspect you know this already. That's my reading. My reading is you get it.
Yeah, I'm not very familiar with containerization, but virtualization I'm okay with. This is Paul.
Okay. So thank you, Paul. I understood that you get virtualization. You use it already, but this may be new, somewhat new to some of us. So that I will take that understanding and then proceed in the direction.
Same thing for me, Nilesh. Anand here.
Okay, thank you, Anand. So let us quickly look at an example virtual machine. This Cloud Genius workstation is actually a virtual machine, as you know already, right? So if you go to the preferences, you will find that this virtual machine, let me bring it up front here. So it is on the other screen. Let me bring it on the screen right now. So this VM is running. If you go to the settings, it has the system with about 1024 MB RAM, one processor assigned. Out of 8 CPUs, it has one CPU given, dedicated. On the memory base, out of 32 gigabytes of RAM, I have given it 1024 MB, which is 1 gigabyte of RAM assigned to this virtual machine. On the same machine, if you look at storage, out of the hard disk space available to me on this machine, the real machine, which happens to be these storage devices, I have given about 2 terabytes of disk, but my actual disk is only 500. So can somebody explain to me what's going on? Like my actual disk is only 500 GB, but I have given 2 terabytes to this virtual machine. How do you explain that? Anybody?
Using storage in the cloud?
No, there's no cloud here. It's all local to my machine here. So I have a 500 GB of flash storage. That's my primary hard disk. And these are external disks, so we're not using them. But the primary disk is 500. And I have allocated actual size is 22, but virtual size is 2 terabytes. What does that mean? These two things. And the real storage is only 500. So what is going on? How can I possibly allocate 2 terabytes when I don't even have it?
So is that 500 GB is only for the main? It's for your main, not a virtual machine, the main processor or the core, and then the rest of the 2 gig and other swap. So is it like a
Ignore
branching?
Ignore these two. Ignore these 3 TB and the other 500 external drives. Ignore them. Ignore this. I'm not actually using them for this virtual machine. So focus.
Yeah, right. So 500 GB is the main driver one, the driver, which is the main OS, the guest OS, the host OS.
Yes.
And the 2 terabytes is the guest one, right?
So the real hardware is only this. In the guest, which is our workstation, the virtual machine, I have allocated 2 terabytes. What is going on? How can I possibly do it? The answer is these are dynamically allocated. Meaning, in real life, it is not really 2 terabytes, but probably about 22 gigabytes. as you can see in this example. It says 22 GB is the actual size. The virtual size is 2 terabytes. That's the upper bound, which is in theory going to be as big as this. In practice, it is actually this. However, if I add more files and more stuff to the virtual machine, then it will grow to 23 GB or maybe 25 GB or maybe up to whatever capacity left here. But beyond that point, it will fail. It's going to fail, absolutely going to fail, because there is no real hard disk to take into account the actual needed storage. So it will start failing at that time. I have made it dynamically allocated. As you can see, the example is, it is dynamically allocated hard disk, meaning it will grow as needed. You don't actually occupy all the space needed right away, but it will grow. When I created the machine first time, it was like 2 GB, and then I've added more applications and SDKs and libraries and tools and other things. It has grown to about 22 GB expanded. It will further grow depending on whatever I add, or shrink if I remove. But the 2 TB is the virtual size. The OS thinks that it is 2 terabytes, but in reality, it's actually only 22. So that's the disk scenario. This is the concept of storage virtualization. You're allocating something you don't have. Right? This is the storage virtualization aspect. In here, you're looking at the memory available, 32 gigs of RAM. In the real machine, you have memory, 32 gigs, out of which only 1 gig is given to the virtual machine, this workstation. In real life, in the processor availability, I have 8 CPUs. Only 1 is assigned as a dedicated CPU for this virtual machine. Similarly, if you go to display, for the display memory, I have, I think about 4 GB of display memory available, out of which I have assigned only 64 MB of display memory to this VM. And I'm going very, very, very narrow, very small in terms of very miserly in terms of my allocations to this virtual machine. I can actually give it more, but I'm not doing it, because I want that virtual machine to work on a variety of machines worldwide, wherever my people who are using the machines, they might not have as much resources. So I'm giving it only the amount of resources it needs. Same audio. There is actually a sound card on the real computer. However, I have disabled sound in the virtual machine. I can actually enable music to play in the VM, but there is no point. We are not playing music in the virtual machine. So we can, but we are not doing it. There's no need. Network. In the network, in real computer, I have like couple of different network connected right now. I have a Ethernet connection, Wi-Fi connection, a VPN connection, bunch of other connections not used right now. And so these are the 3 active networks that I'm currently showing green. However, in here, I have connected only 1 adapter, which is a virtual adapter. As you can see, it emulates Intel Pro 1000, and that's a completely emulated adapter for network. That's what you see here for NAT for the machine here. If you go back to that machine from within and look at the network capability here and say ifconfig in this machine, you will see that it has this Ethernet with a hardware address 3 Charlie 6 Apple. That's the hardware address allocated to that Ethernet. If you compare that with here, it is the same 3 Charlie 6 Alpha, 3 Charlie at the location here. So the idea is, let me adjust a little bit here. So you should see a spotlight there. That makes it easier to read, I guess. So here, 3 Charlie 6 Alpha, that number is the same that you see here, 3 Charlie 6 Alpha. And that Ethernet is emulated. It doesn't actually exist. So this MAC address is fake. And that's what you see that I have given to this virtual machine as a fake device, which actually works like real. Same with ports. You have, you can enable serial ports, COM ports, USB ports. You can share folders and provide a user interface that you want to have from the usage perspective. So the idea behind a virtual machine is that it is fake. It is unreal. And you've seen some videos that I have posted on the Cloud Genius website. You may have seen these videos where I describe what a virtualization actually is. And basically, you take a real computer and you divide it into smaller parts, and you then create a smaller machine that you want to actually use. So you allocate resources available to you and use only this much for a VM. And yes, you will have a power button, on-off button, shutdown button, audio, keyboard, mouse, display, everything that's needed on a computer. But in the context of cloud, you don't need sound card, you don't need display, you don't need a keyboard and mouse. And so you just cut them out in the context of cloud. You can have them in real life. Like the workstation actually has a display and a connection to keyboard and things like that. In the cloud machines, you don't see a display. You don't have to. There's no need. There's no sound card because there's no need. And so that's the scenario in context of cloud. And what in virtualization we do is we actually carve out a physical portion of the real box and dedicated it to a machine that pretends like a real machine, but it is not. Then you add operating system, then you add applications, and then you use it. And so that's how the scenario of usage is, which is okay. I mean, we have been using this for many years. I think about 50 years. Since IBM mainframes, also known as Z systems these days, that's the new name, they have this concept of a logical partition, which is where it began about 50 so years ago, before I was born. And so that's where virtualization is an old ancient story, old ancient technology called virtualization.
Oh, is the Z system on the mainframe the same?
Yeah, the same thing.
Oh, I see. Okay.
And so it's just a new name. New as in, it is also old, about 20 years, maybe 10, I don't know how many, maybe 20, maybe more. But forget the timelines. The idea is IBM's old mainframe systems had this virtualization technology for 50 years now, so it is not new. Now, given that, we have used virtualization as the foundation for cloud computing since cloud computing started. However, there are certain drawbacks to this virtual machine business. And that's where containerization comes into play to help alleviate some burden. Now let us look at the burden part. I'm talking about burden. Burden, as in something that I don't want. I want to cut burden, cut unnecessary wastage.
Oh, can I ask a question on the virtualization again?
Yeah.
So virtualization, I kind of get it. So is it so you have a guest OS, but virtualization is on top of the OS, right?
So guest OS sits on a VM. This is called it fake hardware.
Oh, I'm sorry. Virtualization is on top of the host OS, right?
Okay. So the host OS is not necessary. And I'll clarify further what I mean by not necessary. In my example, in your example right now, yes, you have a host OS, and it is actually necessary. And so in my example, the host OS is Mac. And on top, we have a layer. This layer is called VirtualBox. And that layer helps us create fake hardware. This is the hardware that I just showed you. It is fake. And there I will install Cloud Genius Workstation, which happens to be an Ubuntu OS, by the way. That's the scenario. So let's recap in virtual machine. In virtual machine, in my scenarios, you have either Windows or Mac or some other sometimes. That's the underlying host OS. And then on top, you will put a thin layer of what is known as virtualization layer. This is sometimes also referred to as a hypervisor. virtual box is in our example, virtual box, that's the layer. It creates machine, VM, another machine, maybe bigger size VM, maybe really big machine, virtual machine, VM. So small, medium size, big, any size you want. And then you put operating system here, OS, another OS, another OS. And then you put an application on top here. So call it application 1, application 2, application 3. And so that's the scenario of usage. And there is a lot of redundancy here, redundancy. It is the department of redundancy department. That was a joke. So the idea is we want to cut that redundancy, and I will show you how we do actually. How do we cut redundancy? And I will illustrate that point. So let us understand this VM one more time. So in the context of cloud, they don't have Windows as the host OS. They don't have Mac as the host OS. What do they have? They don't need a guest OS. Oh, sorry, they don't need a host OS. Don't need a host OS. So what do they do then? So what they do is they run what is known as hypervisor. It runs directly, hypervisor. It runs directly on metal, the silicon, the whatever you have, the box, directly on the box. It runs directly. You don't need a guest host OS at all. You don't need Mac. You don't need Windows. You just run the hypervisor directly on the metal, on the silicon, the box itself. An example of this is Zen hypervisor. And here, the Zen is actually a OS. It's a full-blown OS that actually supports virtualization, which means you can create a small VM, medium-sized VM, large VM, super large VM, and things of that nature. And in these VMs, you can then do whatever you feel like. That's what is going on in the cloud computing scenario. When you go to console.aws. Or maybe DigitalOcean, so you go here in DigitalOcean and you create a droplet. That is exactly what is going on, where DigitalOcean will let you choose a size. Small, medium, large, very large, very, very large, insanely large, things like that. And so that's what you're looking at. Small machine, medium machine, big machine, insanely large machine. In here, you will pay $640 per month. Underlying, there is some hypervisor. It doesn't have to be Zen, and DigitalOcean does not use Zen. They use something else. We'll find out what. But they directly run it on the box, the metal. There is no Windows, no Mac here. You don't need it. So cut that. They have cut it already. So what we are now going to use is a scenario where you have a hypervisor in which you have a VM layer. These are VMs. And then each of these, you have to have an OS. And then you have to, let's say you want to run WordPress. So to run WordPress, there are some dependencies needed to make it happen. So these dependencies that you need to have is known as LAMP. You need Linux, Apache, MySQL, PHP. That's what you need, LAMP. So Linux is the OS here. Then you have to add Apache and then MySQL and PHP. And then you add WordPress software on top. And then you get WordPress that you can use. So that's how deployments actually happen. Now, if you want to run 3 WordPress instances, what will you do? You will have a hypervisor. You will put Linux. You will put Linux again. And you will put Linux again. Then you will add Apache. Then you will add another layer of, let's call it PHP. Then you will add MySQL. And then you will have WordPress number 1, WordPress number 2, WordPress number 3. And so what you're doing is repeating this action over and over and over and over and over and over again. That is not good. I mean, you can cut all this, can you? Imagine there is a way in which you can cut. And imagine if there is a way that you can reuse some of these guys here. And that's the scenario we have to think. And that is where containerization is coming into play. And I'll elaborate more on that. So that is what we want to actually accomplish, is if we can cut this redundancy, because this is WordPress number 1 and this is WordPress number 2. So different, it's not redundant. These are different things. The WordPress number 3, different application. But MySQL database itself, PHP language itself, Apache, the application which is running a web server, is also same across the board. Linux is the OS you want to have across the board. So you will install Linux here, then here, and then here. And then you see where the redundancy is coming from. You want to cut that. And is there a scenario where we actually can? And it turns out that in Linux, there is a concept called C groups, which allows sharing of resources and clear distinction of boundaries between what are known as containers. You can actually create control groups using control groups or C groups. You can create well-bounded areas within the operating system. So if you have Linux underneath, okay, if you have Linux here and you use control groups to partition the Linux operating system and the underlying hardware resources in a fashion so that your containers, let's call them C1, C2, are using the same underlying kernel, same Linux kernel. And in addition to this control mechanism for limiting any interference between this and this. So it's totally isolated. And that isolation happens through this concept called control groups. And you can even define size, how big or how small these containers will be. Whereas the isolation is absolutely totally in place, meaning C1 doesn't know C2 exists or even on the same box. So conceptually, if you think of isolation, it is pretty much like you have a table, and on the table you have a laptop number 1, laptop number 2, and iPhone sitting here, and there is no Wi-Fi, no Ethernet, no nothing. So this laptop number 1 and laptop number 2 cannot talk to each other. They're like completely isolated, right? They cannot interfere, cannot interface. There is no Bluetooth. There's no network connection. There is no physical connection. So they cannot talk to each other. They don't even know that there is such a thing called laptop number 2 exists. The laptop 1 will not even have any idea. So this is a table, right? Physical table. You put a laptop 1, laptop 2, they don't know that the other guy exists, right? It's totally oblivious to the fact. And that's the extent of isolation we can actually accomplish by using control groups and create logical containers within the same kernel. That underlying, it uses the same kernel, but it is totally isolated. And that's one feature set. There is another feature set in Unix, and that comes from this idea of a file system, which is not your routinely understood file system, but is a concept called layered file system. And that means that if you have an idea where you basically create a copy when you write, create a copy. This is called copy on write technology, or COW. And so what happens is, if you have a file system in which you have Linux underneath, then this is just like freshly installed Linux and nothing else, right? No, now you want to install Apache. So you do, but when you're installing Apache, you're basically writing something So what you actually do is create a copy, and that becomes another referenceable point where you can refer to this layer and this layer separately on the layered file system. And that is copy and write technology that enables a layered file system, is one of the ingredients to enabling containerization technology and its usage in Docker. So if you add these layers, so let's say you have Apache added, then say you have PHP added, and you can you can basically carve out. Let's say you install MySQL application, which is a database, and you have these 4 layers that you can refer to. So these 4 layers called the LAMP layers, L-A-M-P in this example. And now if you want to create WordPress #1, you will install that. That creates another its own layer. So this is the WP1 layer. However, this layered file system, when you install WP2, it will basically reuse these components without messing around with what WP1 is doing with this application install or this operating system kernel level. And that's the scenario which is enabled in your, the file system, I think is, let's see what the name of the file system is in Docker. The name is, I think AUFS. I'm not sure exactly what the name is, but let's see what the name is. I think there are a couple more different file systems available these days. And so I think it is, where is that? Union file system, Union FS, and there is one more, AUFS. So I'll come up with the exact names and I'll give you links to read more about them. But let us get to some quick examples. So in our virtual machine here, you are looking at is this concept that currently, if you run Docker and say if you have anything in any process running, it will probably say no, I don't have anything running. And if you clear my screen, run that command and identify any images that I may have already. No, I have nothing. So I'm just quickly checking if I have a clean point to start describing the concept. And what I have described up until now is these 2 concepts of a layered file system and a control group implementation to isolate containers from each other. And now, as you know, this current operating system that I'm running here in this virtual machine, do you know the operating system's exact name? Let us find out. The name happens to be this, Ubuntu 14.04.4 LTS. That's the complete description, right? So remember that that's the operating system that I was able to find from this lookup. And so we have it now. Now you just watch me carefully as I install a completely different operating system on this same box in few seconds. Watch this. So what I'm doing is pulling a operating system and I just have it now. So I have pulled a new layer for this OS called BusyBox. And I pulled 2 different layers, this and this. And now I have a image ready called BusyBox Latest that I can actually put to use. Similarly, I want to install another operating system that you probably know already. It's called CentOS. And so I'm going to pull the layers that are needed to create a CentOS-based computer, CentOS-based container. And that is what is going on. I'm going to pull those layers. It'll take maybe a few more seconds. And then I will have that image ready for me to play with in my computer right here, right now. And then I will actually create containers that will run CentOS, which is a variation of Red Hat Linux. And you will see these things happening live as I demonstrate. Up until now, I have downloaded 2 images and I have them here. One of them is CentOS and the other one is BusyBox. So if I see that they were created 2 weeks ago, somebody's created them. This was created 3 months ago, and I have the image ID here, and then this other image ID. So these are images available for me to use in my repository right now. So what I want to be able to do is create a new container and connect to it, but I want to use BusyBox to begin with. So I will say Docker run interactively and give me a teletypewriter so I can interface with it. And by the way, please use BusyBox. And I want to get a bash prompt inside the BusyBox. And so please run it for me. And so that's the command to run it. Now you will know that when you want to start a new virtual machine, like the Cloud Genius Workstation, for example, or this DigitalOcean Droplet as another example. You know how much time it takes to have a new Droplet started up? You know, you've done it before. Takes a minute, sometimes 2 minutes to create a new Droplet and actually getting it ready. Takes about a minute or two. But in case of creating a container, which I'm going to create right now, and I'm going to run it, and I want interactive control over it, and give me a teletypewriter so I can type into it using the bash shell that I want to run inside that new container, which, by the way, I want to use the BusyBox image. So that is the command I will invoke, and you will be surprised how quickly it runs. And you will blink and it will be running like this. Bash doesn't exist inside that BusyBox, so we have to find out something else. Meaning that container does not have bash. So maybe I should try CentOS instead of. CentOS has bash, BusyBox does not. So we'll run CentOS, and then inside CentOS kernel, we will use bash to run it, operate on that container interactively. And I'm going to hit this command with a different operating system image, this time CentOS, and here we go. And so we have it. We have a new machine now, connected, logged in as root, and the machine ID is different. As you can see, the prompt is also different. And believe me that it is a different machine, different container. How do I prove it? By showing you that I am actually dealing with CentOS right there. And if I want to say sudo apt-get an update. This is, by the way, a Ubuntu command, as you know. It will fail on CentOS because CentOS doesn't do apt-get. They have this concept of yum. And so yum will work. And it worked. It is working right now. It'll grab the updates for yum. And so you can see yum doesn't work on Ubuntu, but it works on CentOS, and that's what's happening right now as you see it. Now that is great. What if I just look at my file system and I find that I have this slash, let's see the path. I'm going to echo the path here, $path. And in the path, I have user local bin, user bin, and user sbin. So there are some important files stored in the path, some of the executables. Similarly, I have this library, library user lib. So what I want to be able to do is shoot myself in the foot right now. And I will illustrate the point for a reason. I want to shoot myself in the foot and make this machine totally useless. How do I do that? Something like say rm-rf and then go /usr/bin. How about that? Should I do it? I'm going to do it. So here we go. I killed it. I killed my user bin folder. Similarly, I want to go rm-rf/usr/local/bin. And it says rm doesn't work, meaning I succeeded in shooting myself in the foot. So I cannot remove anything now. My machine is basically useless because I have lost some of the fundamental capabilities of adding and removing files, and all the binaries that I have in my machine, I just killed them. And that is unfortunate. But you know what? I am totally isolated. As I said before, what I just did was in that machine that I have, Ubuntu, I created a container here running CentOS. And that container, I have this command prompt on where I removed my user bin and all the critical files in that folder. I just deleted all of them. And what I want to show you is that it is totally safe to do so, because this other thing is completely isolated. Anything else is completely isolated. It's a self-contained container. That's why it is called a container. A container, use of the word container comes from the word containment. It is totally isolated, locked out, contained, well contained. So you cannot really destroy anything, disturb anything else beyond the boundary of the container. And I just did that, killed my own container. And here we go. I have basically rendered this thing useless. Now I'm going to exit. And I came out, and here everything works. So I can actually create and remove files and all of that. It hasn't even been disturbed at all. This machine is actually the Ubuntu machine that we have been using all along, and it is totally welcome, totally fine. It does not matter. We can do whatever we want inside the container, including shooting ourselves in the foot or killing ourselves, and it is totally okay. Nothing else is impacted apart from you shooting yourself in the foot. Now, having done this, let us play a little bit more to understand this concept very clearly. So here we have Docker images. We have 2 images, right? You remember that. Now I want to see some of the things that are the container I created. The container I created, I want to see its dead body because I killed it, right? So here, let's see the container's dead body. In fact, if you recall, I created a BusyBox container and I attempted to run bash inside, and I basically saw that it got created, but it could not run, and then it exited because I have nothing to do because bash did not exist. So this container using BusyBox image is dead. Container was this number. Similarly, then I created a CentOS based container with this unique ID, and I ran bash inside that I just exited about a minute ago. And you saw that. And these are the dead body references that you see them here and here. And I can remove those dead bodies if you like, but we'll do that later, not right now. So what I'm doing is start one more container, something like Docker run interactively and give me a teletypewriter. That's the 2 things that you need to remember. And then this time I want to run Debian, another Linux, and give me bash inside that Debian. But you know what? I don't even have Debian. So my images are CentOS and BusyBox, 2 different images, but no Debian. But I still want to run it. So what happens is when I run it, it will go grab that Debian image from the internet, download it, and then run it as soon as the download finishes. The download is actually going to download an image called Debian from Docker Hub. So it comes from this location. Those images are coming from here. Let me log in. And by the way, you should create an account. It is free. Docker Hub, you should create an account, and you can see that here. You can search for Debian or just any image that you like. Almost every company worth their salt has an image for their own thing that they do here. So Debian was pushed 11 days ago by the creators and maintainers of Debian, and that image is what I intend to use right here. And so the Debian was pulled, and a newer image is available. And this F28B, whatever, Charlie, that number is the container ID that is now running Debian, because I have it now. So I'm going to test, what do I have? Is that me or somebody else? Hold on, let me mute. Or is it somebody else, I think? Okay. So the thing that I was doing is this cat, its release is going to show me what operating system I have running. And you can see that it is running Debian Jessie. And so inside this Debian, you can examine the file system and you can go to /usr/bin, and it has all the things that is expected. They have it. It is completely a different machine in a completely different container than this dead container, which I killed. But other things that we have are totally safe. So this new container based on Debian is currently active and new. And I have a bash shell prompt, bash shell available inside the Debian container. This is CentOS, which I killed. But I can have another CentOS that I want to run very, very easily. What I will do is go here, make my terminal window a little smaller, like this, and open another terminal. And in this terminal, I have Ubuntu. And I'm going to run Docker images to see what images I now have. So I have Debian, which was updated, by the way, 11 days ago, as you know. You know this because it says so right here. 11 days ago, it was pushed. And so we also have CentOS, we also have BusyBox. And so in this window, what I intend to do is make this window a little more smaller. And then I'll run CentOS image, one container, new container based on CentOS. And so I will like to open another terminal and examine how many dead or alive containers I do currently have. So I'll say Docker, Docker ps-a. Excuse me. So in here, I have a Debian container that is running. 3 minutes ago, it started, and other guys are dead. So I will make this window a little wider and small at the bottom, and then keep it active for us to inspect as we go along, creating more containers on the same machine, and keep an eye on what they are doing. So we have this is up for the last 3 minutes. These guys are exited and created and dead. So in this window, which I'm going to adjust the size a little bit, I want to run Docker, run a container for me, use CentOS, and give me the bash prompt inside. And so here it comes. Now we have another CentOS container. It's a different number. So I will now look at my images. And I have a CentOS container that started about 9 seconds ago. And this other container, which is a Debian-based container that I have started 4 minutes ago, and the other two are dead. And so now you can see that this container is a different number than this number. And so it's totally different entity, and they are isolated from each other. And you have a scenario right now with a machine that runs the Docker infrastructure, which gives you the ability to create containers C1, C2. And in this container, we have image uses CentOS. In this container, we have another image uses Debian OS. And we can have more. Like, for example, I can have Ubuntu running on Ubuntu. For example, let's get one more terminal. And in that terminal, I want to run, adjusting the size. Here, the third window that I have opened up, this one, I want to run Ubuntu on top of Ubuntu. So I can do that very easily. Something like, say, Docker run -it, and then run Ubuntu on top. And here, I want to run bash. And since I don't have the Ubuntu image, it will download it and then run it. And this is going to be a separate Ubuntu installation running in a container on the Ubuntu virtual machine that we have running here already. And so you see that it is downloading right now, and it ran Ubuntu latest, and you can see what operating system it has by checking for the release. And you will find that this is actually a different Linux 1604 as opposed to this one, which is CentOS, and this one, which is Debian. This is running Debian Jessie, this is running CentOS 7, and this is running Janial Xeros 1604. And the actual machine underlying is running your Ubuntu 1404, so the trusty Tahoe. That's the VM that we have been using all along. And these three containers that we have, one running CentOS, another one running Debian, another one running Janial Xeros. They come up with funky names. Janial means hospitable. Xeros means squirrel, is what I understand. They just come up with random names. Tahar is a Indian goat, and it is very trusty for some reason. But whatever. So the idea is that we have C3 running Janial, and the underlying operating system was trusty. This is also Ubuntu. And you can pull this off with 3 independent containers. So you can run any number as long as the underlying machine will support. The resource requirements are very, very minimal. So you can actually comfortably run a few containers, no problem, even on this virtual machine. If you have a real physical box, you can run probably more. The scenario essentially is these containers are independent of each other and are independent of the underlying thing, completely isolated, but they are sharing the underlying kernel. The kernel is provided by this guy right now in this example. So each one of these guys is actually sharing the same kernel, and they put these layers that we add, that we have, that whatever downloads, so Docker images, these images that come down, so Debian image and CentOS image and Ubuntu latest image, that actually is the images that we have, and BusyBox also. These guys that we have images downloaded are only the differences between Debian and Trusty. So they're basically using the same underlying kernel. Whatever else is needed is what is added to the Debian image, and that image is used to create this container. Similarly, in Janial Ubuntu, the difference from Janial and Trusty Tahar, whatever that difference is what this image actually contains. They are going to reuse this underlying kernel. And that's the idea of reducing redundancy. So that's one way to think about it. But you're using images from different operating systems. Most of them are basically Linux based. So that's why you can actually pull this idea together as long as you don't have Windows there. So if you try to pull Windows here, Windows doesn't share a kernel with Linux, so it will not work. No, not right now. It will absolutely not work because the kernel is not the same. In here, you can actually reuse the same kernel component, so it works. And you're looking at 3 different containers running right now. You see here 1, 2, and 3. 3 different containers running on the same physical box. I should call this physical box because it's not a physical box. It's a VM, but for practical purposes, you can treat this as a physical box. So at this moment, I would like to understand if there are any conceptual questions before I go into the next level of creating layers and understanding and playing with it, and then give you this idea about how this is going to be used in the days example to actually take this. We'll do more of Docker, by the way. This is just an intro. We're just starting to play with it. We'll do more of it. And Docker, by the way, has created a fabulous, fabulous service called Docker Cloud. Docker Cloud, which is what I think you should sign up for. It is free. And so you just log in using the same Docker Hub account like this, and you get access to some free services there. So make use of them. and I'm running production services right here, right now. Cloud Genius site is actually running in Docker Cloud, and we'll play with it more. But for right now, I'm just saying, create an account, start learning, start figuring out what they give, and it is free and it is open source. So take it. Cloud.docker.com and hub.docker.com. So 2 links. I'll paste them if you like. But Docker Hub, Docker Cloud, sign up, 1 login, common, free, open source. And this application that I'm talking about is actually uses Docker underneath. And you can read more about it, but we will actually install and get it to work on our own infrastructure. We'll get to that point momentarily. Before we jump to that discussion, I want to ask you any questions you might have on this quick intro that we have about our running containers on top of an Ubuntu box. And just remember, no Windows here. So you're able to cut that redundancy by reusing the underlying kernel and just adding components that are needed to make CentOS function like CentOS by reusing the underlying kernel that the underlying box gives you. Same thing with Ubuntu. This was Janial. This was Trusty. And this, the third one was Debian, Jesse. So we have 3 containers, C3, C2, and C1, 3 containers running. And each one of them can actually make use of the underlying kernel, which is common to all Linuxes. Try adding Windows, it doesn't even work. So there is no room for it. So don't even think like that. So as long as there is no Windows, as long as you do not have Windows in your infrastructure, you can actually use Docker comfortably, no problem. But Windows is coming is what I understand. So Windows support is coming. We'll know when it comes, whenever it does. So currently the date is announced to be 2016, and we are halfway through it. But we'll find out more as to what announcements come out from Microsoft about Docker support. And for right now, Linux on Amazon, Linux on Azure Cloud works just fine. So if you know this thing, this Azure Cloud, that is exactly where Docker is running Linux for me, and the Cloud Genius services are also running on the same location here, Docker Cloud, and it is running the site called Cloud Genius right now. This site is actually running on Docker Cloud, which is running on Microsoft Azure using all Linux. That's what you're looking at, and you will see this actual implementation, and maybe you will have your own implementation for which you will require Docker Cloud account, Docker Hub account. So please prepare a login and start reading about it. We'll do some more exercises later. Any questions on what we just discussed on this 3 different OSs, just in 3 different containers? And you can see more examples how we will build layers on top. We'll reuse Apache usage, for example, PHP usage, and in some cases, MySQL also be used and reused across if we are creating commonality and cutting down the discussion that I wanted to have before all along, which is to cut the redundancy that we will run into in running hypervisor and VMs. So VM1, VM2, VM3, if you want to do the same thing that like I just did using virtual machines, what is needed? You would take a virtualization solution. You will create 3 boxes, VM1, VM2. Right, the same thing if you want to accomplish using VM3, then you start installing the operating system called CentOS here, and then another operating system called Debian, and another operating system called Ubuntu Janial. What you're doing is you're redundant, the kernel component here is common, and that you want to reuse from here. And everything else is what you bring along from your outside image sources, like we just did. for a CentOS image, Debian image, and Ubuntu Jean image. We were able to cut down this redundancy, this one. It is not a small component. I'm just don't have enough room to write. So I am making use of the underlying kernel by not using virtual machine technology, but instead using container technology. And we are able to reproduce same conceptually separate, logically separated, isolated containers, 3 of them, for us to deploy whatever we want to use it with. And they function just like an independent standalone machine. But it is very, very lightweight. In fact, if you look at the weight on this box, let us identify how much it is doing, running 3 containers right now. So let us go see some performance. And here we have, what are we looking at? The CPU is like 4.2, 3.4. Memory is 638 occupied, and swap is somewhat occupied, but then this is not heavy duty. We are running 3 containers on top of a tiny little VM. So it is very efficient. Now try doing that with a virtual machine. You will have 3 VMs. It will bring your computer to knees. It will start crawling, and you don't want that. So you want to actually avoid redundancy, and you see that performance chart live as you see 3 inactive containers up and running, doing nothing much, but that's just the idling. There are 3 containers idling right now. Try same idling on a VM scenario. Your CPU consumption will be heavy. You can see some of it right here. You see that in real machine. I have Zoom running about 67.5% CPU. BitTorrent sync is, I can maybe quit. And then I have other things that are running, such as VirtualBox is running 6.2% CPU. And that 8.3% CPU that you're looking at is actually what is here. All of it is that virtual machine that I looked at in the earlier real machine. This one, VirtualBox VM. This consumption of about 39% CPU right now is the service running the whole story here on this screen, which in turn only consuming about 14 or so % for 3 idling containers, as you see in this example. So bottom line summary is, it is lightweight. Lightweight. And some people tend to confuse the word lightweight with light duty, but don't confuse that. It is heavy duty. There's nothing to do with the duty it can do. It is heavy duty, but it is lightweight. The weight is light. It does not have fat. The fat is cut. We have reduced the redundancy, and that is what we want to be able to accomplish, and thereby allowing us to do heavy duty tasks by cutting unnecessary things that we don't need to. And we will do more examples to get you more clarity in terms of what we just discussed. And let me quickly check if we have any questions with you guys about what we just talked about. There are some things. Go ahead. Yes.
Well, you know, the VirtualBox, you already have Docker installed. I was just wondering, you know, how involved is it to install Docker? And second, if I just, you know, have a Windows box like Windows 10, I understand I cannot run a Windows container, but can Docker runs on Windows?
Yes, yes. It started today, by the way. Today there is DockerCon going on, and there is a new beta release available. Docker on Windows is announced today. Hold on, let me pull up that news that came out today. DockerCon just started in Seattle this morning, and here's the announcement that came today. And the announcement is you can Docker for Mac and Docker for Windows beta testers. So I'm a beta tester, and you can, I think, join the beta. No big deal there. But maybe if I can give you a link to this, I'll just forward this email to you guys. So that will do. So you can see what it can do. Forward to a friend. There we go. So I'll forward to all of you, and so you can participate in using Docker on Windows machines. and Macintosh machines and things like that. So you can totally play that game if you like, but you have Docker already on the virtual machine here. So it is already pre-installed. If you want to just test it, play around, that is already there with you. You don't need to wait for the beta. The beta seems to be very slow today because tons and tons of people are hitting Docker. And it is DockerCon going on. So today is the big day for Docker right now. So you will have some slowness on the sites and services with Docker because lots of people are, it kind of bounced. Okay, forward to a friend. So I can do that if you like. Or why don't I just take this email link and post it in Slack chat and you forward it to yourself? How about that? To do it yourself, I'm just pasting a link. There we go. So there is a question here in chat. The question is for the commercial examples, they run the VMs on varying number of cards. Seems like I remember I had a single machine supporting multiple CPU cards. Yes, they actually in real life, in the context of cloud, they actually build in hardware, open source hardware. Let me pull up the example, open source hardware for and so there is a reference design with HP and Microsoft, big companies getting together that have come up with, I think, an open standard for hardware that gets deployed. So let us see, open source cloud hardware grows up fast. Let's see what comes up. Maybe some pictures. Yeah. There is a picture of a 12U server. Where is that? Okay, page number 1. And there we go. So Microsoft donated its design of a 12U cloud server. And that's what this is. So Microsoft Open Compute Move. And this is the Open Compute project. And where is the link for that? Okay, Open Compute project. So let us read that thing. That will give you the exact specification for machines that are currently popular for deployment. And that's the link. So here, read that. That will give you more ideas and insights on the hardware used for cloud usage these days. So that was the response to Paul's comment. Paul, if you have further questions, please ask away. I will now read Srinivas's question.
Okay, thank you.
Thank you. Srinivas is asking, so primary difference between VM and container is that kernel is shared in the containerization, whereas VM has their own kernel. Yes, it's a correct statement. VMs are fat, Docker containers are slim. Yes, and kernel is just one element. There are other things you also reduce redundancy, as you will see when we do more examples with a slightly higher level than just the operating system. As we add applications, you can see the kernel layering. There are more exercises to deal with this coming along. And excuse me, let me close some of these tabs. And if you go back to this location, where is that? Now here you will find a set of things that I would like you to do on your own with Docker. And that is in, where is that? Here. So module number 16. There are some hands-on examples I would like to play with, like you to play with themselves by yourself on your own. There are some interesting examples that I have here that you may want to play with later on. But that is what gives you some idea about what is it. And it's ready. You don't have to install Docker. It is there already with you. And so play with module number 16. I will go paste a link for you to play with here coming up.
Nilesh, do they have any syntaxes? Which syntaxes
Yeah, everybody has their own syntax.
Like what is the comment stuff? So
Yeah. So
how to download stuff.
once you go through this link I just pasted, you will understand it. It's not complex. It is very simple. Very simple. You start to learn it once, and then you refer to the man pages. It's simple. Yeah, there is a request for break time, and there is a question also, which is, could you please explain networking components once again in VMbox? I will do that maybe after a break. There's a break request. So right now it is 6:25. Let's take a short break. 6:25 right now, which so break should be like 6:30 Pacific time, Eastern time, 9:25, 9:30. Let's take a break, and we'll talk about the question you have and then proceed forward. I'm actually walking away from the computer right now, so I may not respond if you ask something. I'm just heading the restroom, and I'll be back in a minute. Thank you. Okay, are we ready and back? I guess we are. But I want to check.
Yes.
Yeah, looks like you guys are back. Okay, so the concept of networking component in a VM box. Okay, let's do that quickly. So in RealBox, the network components are, let's see, what do we have? Bunch of different things. Let's understand them. We have this Ethernet. It has a Wi-Fi here, a VPN connection, and another Thunderbolt, a Broadcom, another Ethernet card, a Thunderbolt FireWire connection, a USB connection to the iPhone, a Bluetooth connection, another Thunderbolt bridge connection. So we're not using some of these things. They're disconnected right now, most of these guys. These are real devices. They actually exist. I can touch the wire, like hold the wire in my hand. I can see that the hardware MAC address is like this. And that's the real hardware MAC address, 5A62. And I can actually disconnect the cable. I don't want to, but I can disconnect this cable. If I disconnect the cable, the call will disconnect. So I don't want to disconnect the cable. However, that's the real network. Excuse me. Now we will go to the virtual machine here. This virtual machine, which is currently running those three Docker containers and this monitor, we just go check the if config on that box. You see that this box now suddenly has more containers. What are these guys? Let us take a look. So we have these three containers. So the actual Ethernet connections to them are also represented by virtual Ethernet here. And these are the Ethernet connections allocated to those three containers that you have running. These are virtual. We have a connector for Docker. We have a virtual Ethernet adapter. This is the main adapter to this virtual machine. It has this MAC address. This MAC address is assigned by this virtualization software, which is running this Ubuntu OS. This Ubuntu 14.04 is running the actual operating system on this VM. So that's what you see in the network tab, and that the same 3 Charlie 6 Alpha shows up here that you see here in the VM. So that is the 3 Charlie 6 Alpha. Same thing. 3 Charlie 6 Alpha. This one. Now, where does this get allocated? Think of it as the actual cable, actual virtual wire connected through this wired connection. Now, if you look at this hardware MAC address, again, 3 Charlie 6 Alpha, and go to the VirtualBox interface, like I'm going to go there. I'm going to bring it out up front and see the settings. You will find that the network component, I have allocated one adapter, and it is network adapter. Enable that connection and made sure that it is connected through a virtual router in the VirtualBox software. So it is connected through a router. That's why this word NAT comes in. And I will draw a picture to explain this further. If you drop that down, which I don't want to change anything here, but there are several other options of connecting that same adapter to the physical machine. And I will not change the NAT part right now because we are actually live using it. But I will now draw a picture to explain to you what this thing is.
Yeah, Nilesh.
Yes.
Yeah, I want to know like what other option they have it when we can use it in what.
These options?
Yeah.
Okay, I will.
At the same time, advanced option also.
Yes. I will do that.
Okay.
So let's understand. Get me a sheet of paper, and now let us talk about this. So in your VPC example that you did in the other way, in the other day on your own with Amazon, we had a subnet. We called it border check. another subnet, we called it private, right? And we had a NAT box here that connected to the gateway. And we had these boxes connect through the NAT. That is what exactly is the scenario right now in VirtualBox also, except we have a Mac. The Mac runs VirtualBox. This is the software. This software simulates a router. So this machine Mac has an IP address that looks like, okay, let's see the IP address. This Mac has an IP address of 10.0.1.11. Okay, so this has 10.0.1.11. That's the Macintosh Ethernet IP address, the public IP address from the Mac, from the other home or office router that you have a router here. This router assigns this address to this Mac. Now, internally in the Mac, in the VirtualBox software, there is another router. So this 10.0.1.11 is the Mac address. Oh, sorry, Macintosh IP address, not Mac address. Macintosh IP address. Now, inside VirtualBox software that we have, there is another router that is virtual, simulated software. And when you create a VM, you give it an Ethernet. And this Ethernet, how you connect is what the rules are in this dropdown. By default, the connection is through a NAT. By default, the connection is go through this router. This router is a part of the VirtualBox software, and it allocates IP addresses to this VM. That's the default connection. It's called the NAT connection. There are various ways to connect it. So in your home or office, you have the router here, and that connects to your Comcast or Time Warner, or whatever companies that you might have, and that gives you a private IP. And this is what you see the Macintosh getting 10.0.1.11. But in the Macintosh, there is VirtualBox software, and this software also runs another router. And you may want to use it, or you don't have to use it. So two choices, use it or not use it. When you create a VM, you can create the VM connected here, like this, through the router, or you can have the VM connected directly to here. That is also possible. You can have a VM that is not connected at all, like no connection. That is also possible. You can have, let's see all the scenarios here. So not attached is one scenario, which basically means no connection, like absolutely no connection. It's isolated on the network. That's the no connection scenario here, this first one. The second one is NAT, which is this scenario. You have the VM, you connect it through the VirtualBox router, which in turn runs on the Mac, which has this IP address. And so this router will assign an IP address to this VM. And let's find out that IP address. And that IP address happens to be 10.0.2.15. So different subnet. This is 10.0.1.11. This is 10.0.2.15. So different subnet. And this is the IP address this router gives to this box. And that's what you're looking at in the example. And that's the default connection, by the way. The default is go through the NAT. That's the default selection in VirtualBox. When you get a machine, you better get that behind a NAT, which is this router issued by VirtualBox software. That's the default way of connecting. That's why this is default. However, you can modify it. You can create a NAT network, meaning you can have other VMs also connect to the same router. So it becomes a small network of VMs, but all behind this router, which is a software router. Next one is a bridged adapter. This bridge adapter basically ignores this router completely, and you have the VM, and it bridges straight to that router right there. So when you do it like that, this IP address range will be allocated to this machine, and that real router will assign 10.0.1 something to this VM. And you will see that an entry in the router table here for this box, and that is called bridging. Bridge. This bridge directly establishes through and through all the way to the real router. That's a bridge connection. That was this example, this fourth one. Then you can have an internal network. This bridge also goes all the way to the end, and so it connects through Comcast and gives you public access. So all of that through and through connection is bridge. The internal network scenario does not give you public access. It gives you an IP address, puts you on the internal network alongside this Macintosh. So logically, you will place this VM alongside the same level as your real Mac. Let me draw it one more time, clearing up. So in logical representation, you have a real router, you have the Mac, or I should say Macintosh. You will get a VM, they all participate, and this is the bridge scenario. In internal only scenario, you will not get public IP connections, public traffic connections to the VM. So this VM, although it can talk to the Mac, talk to other things you might have in your office, such as you might have a server. So it will talk to the server, no problem. But when this machine tries to go out to the internet, that is blocked out. That's this scenario of internal network. Another scenario, which is the host only scenario. In that scenario, you have your Macintosh running VBox software, which has a router, and the internal, host only adapter, this scenario, will have the VM connect within the Macintosh and not connect to any other machine out there. You might have a server, it will not talk to it. So this, no connection. To this Mac, yes. That's the host only adapter. It's how you can regulate the traffic flow among these machines, and host only, or within your private network, or all the way to the public through a bridge. So those are the variations you see, and in the generic, I think it is modifiable based on what you want to type, and you can then configure it by hand if you like. And I want to cancel it because I just accidentally modified it. So I want to cancel it out. Settings, network, and all these choices basically represent the flexibility of what you want to accomplish in NAT, network adapter, bridging, internal network, host only adapter with the machine, and a generic solution to connect to whatever you want by giving you an option to customize and not attached at all. So independently isolated box. So these are the 6 options that we have. So 6 or maybe 7, 1, 2, 3, 7 options. Further questions on this, or should we change?
And advanced also. So if
Okay,
you
advanced. So okay, let's go look at advanced. So you want to go look at this section, port forwarding? Or,
no. If you click on Mac and open up, they have a more option, a MAC address. If you can the down on
which one?
before cable.
Oh,
If you-
this is
Yeah.
a random string generated before you start the machine. MAC address basically is a,
No, okay. I think adapter type. Okay, they have a different type.
yes.
So I don't understand what type we need to use when. Like it correspondence, I guess, is attached to.
So let me show you another example. So I'll go adapter number 2. Let's go change it. So adapter number 2 is not being used right now.
Okay.
So I need to maybe identify another machine I can play with, or maybe what I'm worried about is I might disturb if I shut this down. I disturb the setup, so I don't want to disturb it right now. But we can play with adapter 2, 3, and 4 to modify these settings separately in the adapter type, the promiscuity, and the MAC address designs and port forwarding settings. We can play with those later, but I don't want to disturb the live running machine in which I have a demo plan.
Okay, no problem then.
So I need to shut the machine down in order for me to enable adapter number 2, 3, and 4, which are disabled right now. Only one is connected.
Okay, understood. No problem. You can go ahead.
We'll do this later.
Okay.
Okay. So I'm going back to this machine and closing out this, and you see that these 3 adapters, virtual adapter 1, 2, and 3, are basically representations of these 3 containers we have. We just quit them. So exit, exit, and exit. And now we have exit, hold on, exit, exit, and exit. You will see that my machine does not have that many adapters anymore. They're gone because the containers are gone. Containers are gone. Their adapters disappeared along with them. And we only have the Docker generic adapter, a real Ethernet adapter, and a local connection, local network loopback connection. That's what we currently have. We'll also see that there are some dead bodies of dead containers. And we want to clean them up. We want to kill these dead bodies and throw them away, extinguish or do something with it, process them, clean up. There's a cleanup step, which you can read more in the write-ups. And I'm going to just clean them up for you. Docker -f dollar Docker ps -aq. If I remember the command correct, I think that should be the command. Yes. So Docker ps-a. We don't see any dead bodies anymore. It's all clean. Docker images. We should have all those images there that we downloaded before. We can reuse them. The containers and images, what's the difference? And there is something that I would like to clarify, which is, this is how I would say. So people ask this question all the time. What is the difference between an image and a container? When do we use what, and what's the idea? So an image is a file. A container is a runtime use of that file. So you have an image called CentOS. That's the image that you download the file, and it is stored locally. And then when you start a container, you run it, you use that image. And so it's an instance of that image. That's the difference between a container and an image. So don't confuse them. A CentOS image is what we have here. We had a dead body of a CentOS based container that exited, and we killed all the dead bodies and extinguished them. So we have a clean slate again. There's one more question here. Are there any VM versus container questions? No such comparison. What I mean is, does application developers companies choose one over the other? Yes. If you want to use Windows and Unix together, you don't want to use containers. It doesn't work. If you are purely Linux based, you have a great idea of using containers. Absolutely doesn't even make sense to use virtual machines. It does not make sense at all these days to use a VM when you know that you can get with containers all along. Use that. That is the only solution. You want some industry ratification behind it? Let's go read that. So let's see. Google starts how many containers? So the answer is 2 billion. 2 billion containers every week they start. And that's the extent of usage of containers in companies like Google. It is extensive. It is mind-boggling. And basically they're claiming here that everything at Google runs in a container. And this is like 2014, by the way. It's old news. And so that's what they've been doing. There are services like Google Container Engine. So this is a new service, relatively new, called Container Engine, which basically runs Docker. And here you can configure it to run your Docker containers inside Google's platform. But this is Google Container Engine, which is their service implementation. Similarly, in Amazon, they have a service called Amazon EC2 Container Service. That's what you're looking at here, which is running Docker in Amazon. Similar to that, there is Microsoft also has a service very, very similar. And I think the best way to use a container with any of these cloud providers, according to me, is actually the Docker Cloud, because it gives you a uniform access to all the container providers. So let's go look at some settings here. I'll switch the UI a little bit and show you an example of where you can connect and create a Docker cluster on any of these cloud providers. And so that's the scenario, which makes it consistent across the board. You use Amazon, DigitalOcean, Azure, Packet, SoftLayer. I don't have an account there, so I don't have a connection. But any of these companies that I want to use, I can just go here and have them go to San Francisco, for example, choose the machine size and how many I want, and give it a name, give it a tag, and bingo, I launch a cluster. And then I can just run my containers on those underlying 3 boxes, each with 16 GB of 8 CPUs, and off we go. So that's the simplicity that it provides you. It doesn't matter which company, Amazon or Azure or whatever you have. So you could basically choose the size of the machine and then grow, or maybe really make it big. So for example, D3, D5, yeah, here, D5, and I can get 8 machines, and I can get 100 GB, 200 GB size, give it a tag and give it a name and whatever name I want. And then I just launch, and it will go to Azure, launch these boxes for me, and then run Docker platform on top. So I can just deploy my containers very, very easily in form of variety of services. And I'll go more into Docker Cloud as to how it is useful from a real life usage perspective. And but before we jump to this dashboard and make use of it, I would like you to understand the nuts and bolts of Docker before we jump to a visual solution. So we will get to that, but the point I'm driving is that companies are using Docker containers over virtualization, because using virtualization does not make sense when you have only Linux-based applications. It doesn't even make sense anymore. The corner cases which still are useful is when your application is designed to run that does not allow it to run on a container. So there is the scenario of containerization of an app. So you have to containerize your app. Once that is done, it is actually fairly easy for smaller applications. It can be involved a little bit for larger applications. You want to make it modular. You want to make it follow the containerization principles. And once you have it containerized, then it is a no-brainer to not run on a container. That's how it goes. It makes your life simple, saves you money, headache, everything. All of that, all the benefits come along with no additional drawbacks, no additional trouble points. You just have to do this containerization one time. It's a one-time operation of how you think, how you redesign your application. And that is a one-time operation that any large application needs to be done. If you're designing a new application from scratch, there is no other choice but use containers. That's the way to go. There is no other alternative. It doesn't make sense to use VMs anymore from that perspective. If it's a new app, just go containers. And by the way, today, read about DockerCon if you haven't yet. So go read about DockerCon, see what they're doing, and understand DockerCon is happening right here in Seattle. DockerCon. So here, link. So go read that. There are some videos for you to watch. I think you should watch that. Okay, closing on these topics and then switching back to here. So we have killed those containers like you saw and close this. Now let us understand how we can put this platform as a service to run on our own infrastructure as a service. That's what I want to be able to accomplish. And this exercise will take about slightly more than an hour. We are at 7 o'clock right now, so we should be able to finish. We should be able to finish. So let's stay focused on this and remember to watch it very carefully. Avoid doing it yourself right now, but please, absolutely do it yourself later. Don't miss this exercise. It will give you much more clarity on how to deploy large, complex applications in real life. Mm-hmm. This is a fairly complex application. The application itself is a platform as a service. So we are deploying this app called DEIS. That is an app. We are going to take this DEIS software from this location in GitHub and then install it on this cloud, which has nothing right now. So no droplets. We are going to do that right now. And yes, it is involved. So please watch it carefully. And remember, you're doing it on your own, and please do it. If you get stuck, we will do another session. If you want, we'll do an extra session. If you want one-on-one questions, we can do that. But please watch what we are doing is taking this DEIS app. It's a huge application. There are 5,715 commits, and these commits are made by tons and tons of people. And so we are running this, deploying this live as we go along. And so let's begin. So instructions are written down. The instructions can be a little bit cryptic, and that's why I'm walking you through it. It can be cryptic. So it is a fairly new exercise, started only last time when people from Hitachi Data Systems wanted to compete in a case. And so we built this exercise just for them. But I think it is also useful for people who want to understand the general purpose complex PaaS deployments. So with that in mind, I will begin. I'm adjusting the screen size a little bit and begin. So the idea here is we are going to get that source code first thing, right? So we'll grab that source code from that location, and that's the source, and we are here. So we'll go and grab the source code. The first way to do it is just pull it down. So let us see if we have a previous deployment of DEIS, CD DEIS. And no, we don't. That's great. So we'll just do a git clone. We'll clone the whole thing, bring it down locally. It's coming down. And it's a big package, about whatever size it is, about 20 MB. That's just source code. 20 MB of source code is huge. So we have it now. We'll go inside there and we just check out a particular version. This is the version that I know works. And so I'm going to check out that particular version. As you can see, the current implementation may be a little bit different. It is 13.2, 1.13.2 is the current one. I'm going a little bit back here, this one, and that's the version which I want to actually run because I have tested it and I know it works. I am not saying that the newer versions do not work. All I'm saying is that I have tried it. I have tried this version, so that is what I want to try in a real live deployment. I have done it before. This 1.13.2 was released 7 days ago, and I have not had a chance to run it. And that is why I'm going a little bit older, because I know I have seen it working. I'm pretty sure this will also work, but I don't want to take a risk right now. You understand why I'm doing it that way? I hope so. So this is the version 1.12.2. We are checking it out like that. And now we have it, that version 12.2. Great. Next up, we have to set up our access keys. So that's what we are going to do, is get our keys in shape. So we have to generate an access key pair. So here we are generating a new key pair like this. And so you know that our keys that we have right now are in that folder. We know that that folder stores our keys, the .ssh folder, and I have deleted all the keys I have there. So I'm going to generate a new key pair, and this folder does not have any keys, and I'm going to generate a new key pair. And now I have a key and a pair of keys. The name is days and days.pub. That's the name I chose for this key that I just generated and stored it like this, here and here, the public and private key. I just figured that. Now I'm going to generate a fingerprint for this. So I'm going to copy the fingerprint I want to generate for the public key, and that's the fingerprint I now have. I will make note of that. And this is the hash of the public key. I want to now copy the content of the public key into my clipboard and send it over to DigitalOcean. This is a new public key that I have. So I'm going to take this public key and give it to DigitalOcean, like right here. So I need to get my public key so that I can then connect to it, right? So I will go to here in settings, in security, and in security, I will add a key. So I'll say add SSH key. I will paste the content and give it a name. I'll call DEIS and add the key. That's a new key that I just added. And this is the days key. Now I have it. Nice. What I intend to do next is, I think I have tabs open for some reason. I close one of them and bring them all together in one. So I have this tab opening the thing that we are doing right now. And that is what I have done up until now. Is I pasted my public key content into DigitalOcean, and we can compare the hash it generates. The fingerprint it generated is this blue line, and it should match up. It should match up with the fingerprint I generated by hand. So let us match that, compare that. So this blue line should compare with this exactly item by item. Let's go compare. Is it accurate? Yes, it is. It is matching. Echo Delta Alpha 8. So it matched. Next up, we want to create and grab an API token from DigitalOcean. So this API token is how we will connect to DigitalOcean Cloud using our terminal. We don't want to create instances using the screen here, but instead we want to actually go to the API section and create a personal access token in the API, personal access token. And I'll generate a new token and give it a name and then generate. Now I have the token right there. I will copy it to my clipboard and save it. So I will save that clipboard in some editor here. And that is a token you should never share with other people, because if they have the personal access token, they can make use of your DigitalOcean account without your permission. And so you don't want to share this token with anybody. This is your digital access token, DOT. You want to keep it safe. So keep it like, now, having created a token, token will look like this. Save it. You will need it in another step below. So we have this token saved here, and now we will proceed forward. You will see that I will now make a discovery URL. So this discovery URL is needed for multiple containers to discover their brothers and sisters. This idea needs some explanation. So the idea is you will need to create multiple things that need to exist independently, but they need to know that I have a brother here or a sibling there, and then each of them should know each other, right? That interrelationship needs to be established. And so for that, there is a service called etcd. And that service is what we are going to use to create a discovery URL. So these boxes that we will create in DO will discover each other and then participate together as a cluster. That's the scenario we are going to run right now, where we are, what we are doing is creating a discovery URL. As you can see, make a discovery URL. That piece of software is what we need to run. So we'll grab that link, run it right here in the days folder, and say make discovery URL. And this will generate a discovery URL from the etcd service. And the URL is this line. This URL that's the URL we got. It has automatically been written to a file, contrib CoreOS user data. It has been saved automatically there. So if you open the Atom editor in the current folder, you will find this contrib CoreOS user data has been updated with the discovery URL already. This URL was generated through the etcd service. etcd service is a public service available for discovery. And that is what we have created. And if you go back to Atom editor and you find that particular file called contrib CoreOS and user data. So here is contrib, here is CoreOS, and here is user data. And in there, you will find the discovery URL has been already incorporated. It was just done automatically by this command. And that's what has happened. Now, what this will do is create this next command. We will use a software called Terraform, this software, Terraform, to install and actually create new machines right here. So we do not have any droplets, no droplets right now. We will use this application Terraform, which is also open source, to create a cluster of machines for us. And on that machine hardware, we will then install platform, the PaaS. That's what we want to install on some infrastructure. And we want to create this underlying cluster of machines. And we will be using a discovery URL that we have created already. And these three machines we want to generate, not by mouse clicks, but using a tool called Terraform, which is already installed. And it's complaining that it is out of date, but don't worry, it doesn't matter too much. You can update it, but don't have to. This will work just fine. Yes, it is out of date. The tools update so rapidly that anytime I update it, it becomes out of date just the next few days. So Terraform is an open source tool to configure cloud infrastructure. And that's the tool we will be using. This is the tool, the website for the tool. You can read more about it on terraform.io. And it is open source, and it will help us create these droplets on which we will then run our platform. So let's go forward. So if you do not have Terraform already, then you need to use these steps to install Terraform. By the way, we have it already, so you don't need to do these steps. Now we need to be in the days folder, which is where we are. We are in the days folder. And now we have to run this command. This command is kind of complex. So let us watch carefully and understand it before we execute. So that long command that we have, all of it, one shot, we just copy the whole thing. We have to copy the whole thing. So I'll Control C, take it to a notepad and a new, new page, paste the command. I did not copy properly apparently. So I'll copy it again. I'm copying it, bringing it here and pasting it. Now I have it. Now you will notice that there are lots of things here in that long command. So let us see. What I want to have is make sure that our token is up to date. This token example is bad. I'll delete it. But then I'll grab my token that I have and cut it. And then I'll go here and paste my real token. In addition to that, I have to do certain changes, such as I have to modify the SSH keys signature, the fingerprint that we have, which is this fingerprint, which is also incorrect. So I want to delete that fingerprint and get the fingerprint I have created here. That is my fingerprint that I created in the earlier step. So I'll grab that fingerprint and copy and delete this example fingerprint, all out, delete, and paste the correct fingerprint I have for my SSH key, the public days.pub. This days.pub has this fingerprint, which is what I'm copying from this location to paste into the correct location, replacing the old example value. And also I removed my old example token, put the real token from DO site. The token was given to me by the API button where I generated a new token. This token is still visible, but if I refresh the page once, the token will disappear. It is shown to you only once, and then the token will never become visible. All you can do is delete it, but you cannot read it again. It is gone. It is invisible, not gone, invisible, hidden. Now back here, we want to make sure that these tokens and SSH fingerprints are correct. Yes, we did. We want to select a region in New York number 3. I'm selecting NYC number 3. I'm prefixing it with days. I'm choosing to run with 3 instances in my cluster. I will choose a size of 8 GB, and I will use this contrib DigitalOcean flag with Terraform. So Terraform, we want Terraform to know that we want to run DigitalOcean, and in that location, we want to create 3 machines with this key, this token in New York, and prefix the name with days. And I want 3 instances, 8 GB each. And so if I take this whole command, copy it, and then bring it to my terminal, clean my terminal out, and paste it, and then run in one shot the whole thing, you will see that it will go to DigitalOcean. And here in droplets, it will start creating 3 droplets for me. And I will do that right now. Off we go. So it is doing some things. Basically, it is creating droplets for me right here. As you can see, 3 droplets created. They're being built depending on what instructions we have provided to them. And that is what we are interfacing with DigitalOcean using their API token and using our key to connect to them. And it is creating those 3 droplets. 2 of them are ready. All 3 of them ready. Apply completed. We have 3 resources added. And the output IP address we now have are these. So that's what we have as an output. Your hosts are ready to go. Your IP addresses are these 3 IP addresses we got. And that's what you saw in the example that we now have. Good to go, change the world, go change the world. So these 3 IP addresses we now have, days 1, 2, 3, 3 boxes. They, they know each other. They can interact with each other. They can operate like a cluster. And that is where we are going to install this days PaaS, the platform as a service. Now, before we do the next step, we have to set DNS correctly. And this is something that you need to really carefully listen and understand. This is non-trivial, so just watch me do it, and I will make sure to answer your questions. I'll make it a little bit bigger so you can see it properly. And so here we go. This DNS exercise is a little bit different. What we are really trying to accomplish is adding a wildcard DNS record. And what this does, let's see some examples. So wildcard DNS. So you saw this earlier Mr. Salam generated this link, right? And you saw that that link is called Tranquil Beyond 40 blah blah blah, whatever that number is, like Tranquil Beyond 49901. What does that mean? I mean, it's a funky name, and I'm pretty darn sure Mr. Salam did not select that name.
No, I did
It was
not.
selected for him by somebody. And who's that somebody? It's a randomization software that automatically generates some silly names. Like, for example, you will see another silly name in the other example from Tosin. I think Tosin or Tiku had that example. So yeah, these are funky names. You will see Tranquil Beyond. You will see more names like Heroku.com, and I have some apps running there. You can see,
Docker container also randomizedly.
yeah, so see these names, ASD, this is a manually typed name, but let's see, Thawing Meadow 4084. And that's a randomly generated name, Vast Island 55351. So these names are randomly Frozen Gorge, Cryptic Headland, Calm Dusk, Aquos Cliffs. These are randomly generated names. And what they're doing is mapping DNS entry under this main domain. So herokuapp.com is the main domain. And on top, they have chosen a wildcard DNS. And that is where they are generating a random DNS entry and throwing it at a DNS record so that you can, when you type tranquil-beyond-49901.herokuapp.com, it will open up this site. So that's the idea behind this concept that we are talking about called a DNS entry, which is a wildcard DNS. That's what we are really doing. It requires a wildcard DNS, which means we need to have a base domain. So like herokuapp.com here, I want to use a base domain. So my intention is to use, my intention is to use a base domain that I will write down here. And my idea is to use cloudgenie.us. But you know what? That is actually a production domain, so I don't want to mess with it. So I will leave it alone. Similar to what Heroku does, their main domain is called heroku.com. They don't want to mess with it. So they have created a separate domain called herokuapp.com, and they mess with that instead. So similarly, what I will do is not mess with the main domain, but instead create a separate subdomain just for having fun. And this is a separate subdomain that I will now use, and then put a wildcard entry right there. And by doing that, I will then be able to randomly assign something like Tranquil Beyond 49901.hello.cloudgenie.us as the randomly generated DNS name for an application that somebody might deploy to our own platform, which is going to be deployed pretty soon. So this scenario is possible if you actually create a wildcard DNS. That is what we are trying to implement next here, wildcard DNS. In order for this domain, hello.cloudgenie.us as the top level domain, the apps will then live under this syntax, and it should have an A record entry for each of the machine's IP address, which means we have to create, first of all, a name server for this to work correctly. Now this thing is a randomly made up name. I just made it up, like here. It doesn't exist. Just go there, nothing happens. It doesn't exist. It's a randomly made up name. I just made it up for the purpose of the exercise. If you go to hello.cloudgenie.us, nothing. It doesn't exist. It cannot even resolve. There is no DNS server. See, it says hello.cloudgenie.us's server DNS address could not be found. It cannot even find the DNS server. Forget about the server itself. Cannot even go to the post office. Forget about going to the home or the White House. It cannot find the post office. The DNS doesn't exist. We need to first thing first, create a DNS server for these guys. And then in that server, we'll create an entry for wildcard and put 3 A records. And these are the 3 records for the IP addresses we have: IP1, IP2, and IP3. Those 3 records we will put, but first get a DNS server. For line number 1. For line 1, I want to get a DNS server. And do you know how to get a DNS server? You go to GoDaddy, they give it to you for free. But this is not a purchased domain. It is a made-up domain. I just made it up. So you have to buy one. So I'll go and buy one. I'll go to some company that gives DNS. So I want to go to cloud.google.com, or you can go to Amazon, AWS, Route 53, or any other services that provide you a DNS for money. Don't get the free ones. You will have trouble. And I'll tell you why. Get the paid ones. They are properly designed to work with appropriate feature sets. If you go try a free one, it will cause you trouble. And the cost is probably like a few cents. If you operate for 1 or few days, it's going to be like less than a couple of cents. The pricing on a month-based usage of a DNS server is 40 cents per month. So a couple of days, not a big deal. And this is why I suggest when you're learning or beginning to learn, get a commercially managed, properly managed DNS service. And for this example, I'm going to use the DNS, Cloud DNS from Google. Just an example. So here we go. We have, where is that? Cloud DNS. Let's type DNS, networking. And so here we have Cloud DNS. And I do not have any DNS zones, which is understood. Yeah, I don't have any. So I need to create a zone and I'll give it a name. The name is already chosen. The name I want to use is this, line number 1. So I'll just get that name and put it here. My DNS name. Oh, it has to have with no dots. So here we go. Yeah. So that's the name that I want to choose. And the DNS name happens to be the one I want. And then create. As soon as you click the create button, you are agreeing to pay them 40 cents roughly, give or take. I don't know exact pricing for a monthly usage of this thing. They're giving you a DNS zone. They're giving you a zone file. You can then go and edit the zone records, but then you have to commit to pay them money. That's what I am doing. And I recommend that you do the same way, or go the Amazon way, or go a proper, fully featured DNS server. But don't try to save money. Don't go cheap or free, at least for the first time. So DNS, create. It has to be created. So that makes me wonder, what do I do with these things? Now I have the four name servers: Cloud B1, Cloud B2, Cloud B3. What do I do with this? Any ideas? So they gave me a name server entry. Here are your 4 name servers. What do I do with this? Tell me. How do I tell the internet that I have this domain and that these are the name servers? I have to go back to one level below to the main domain, cloudgenie.us, and tell that name server that this hello exists. That's a critical thing to understand. And if you're doing it first time, you have to really think and clearly understand what I'm saying. When you buy cloudgenie.us or some top level domain from somebody, they give you these server entries already. But when you're making something up on your own like this, and you create a DNS server, the world does not know that you exist unless you take these records and give it in form of a name server entry for this line into your cloudgenie.us main domain. So you have, all of you have a domain name. Don't mess with the domain name, create another subdomain and then play with it. Just like I'm doing. I'm creating a hello dot. You can create whatever you want dot. But this domain is the one that you want to go back to. So in my example, you remember I have the domain at Cloudflare. So I'll go to Cloudflare, which is where I have the domain under management. In there, I'll go look at DNS and find out if I have a hello entry. I doubt it. Actually, I do from a previous exercise. So I have a hello entry. So I have the cloud D1, D2, D3, D4. So those entries are already put in from a last attempt at this exercise a while ago, maybe January timeframe, January, February timeframe when I ran the program before. So that's when I have these entries saved. But as you will remember, notice this is delta 1, delta 2, delta 3, delta 4, D as in dog, D as in delta. Whereas our cloud company, Google, has just assigned us brother 1, brother 2, brother 3, brother 4. So we have to change these things. NS Cloud will be brother 1, NS Cloud brother 2. It is different. It is not delta, it is brother. So I need to make these changes. NS Cloud brother 1, NS Cloud brother 2. It's a different server this time, not the same one from the last time. So I'm making those changes to brother from delta. There we go. So I made 4 changes, brother 1, brother 2, brother 3, brother 4, and I saved it. And now the world knows that there is such a thing called hello dot something, hello dot my domain. And so that's how you tell the world that, hey, no, we exist by inserting an entry in the name server records. So NS 1, 2, 3, 4 NS records for the subdomain hello under your primary domain that you have, managed by Google company, Google's cloud solution, Google's cloud DNS. That's what I'm just telling them. So now I can use this interface to manage the DNS zone for line number 1. Now that was involved. So I want to answer your questions. I know there are questions about this, so I will like to answer them. So please ask a question, because this is probably the most involved part of this exercise. If you get the DNS wildcard entry and creating a subdomain and then creating a cloud service and incorporating that name server into another name server, then you are okay. If you don't understand it, ask me questions now, later, in chat, one-on-one, all of it is fine. Now it's better. If you don't have a question, that's okay. So I'll keep going. If you have a question, please feel free to stop me anytime. I'll quickly summarize what I just covered. What I did was, I had this domain and I bought it from some company. That company has given me a name server. This is currently at Cloudflare. That's how Cloudflare. That's how I run my business. Beautiful, no problem, it works. The thing that I want to now do is I come up with a random name that doesn't even exist. This is, nobody knows about what this thing is. I'm just making it up. So I did make it up. And I said, you know what? This is my domain now. So I need a name server. But what is my name server? Who's going to give me one? So I buy one name server from Google Cloud DNS. I go there and I say, hey, here are my 40 cents, or whatever the pricing is, 0.40. And I give me a DNS server, please. And they said, yeah, here, take it. And they gave it to us like this. Here are your DNS record name servers. So go take NSB1, NSB2, NSB3, NSB4. You got 4 name servers. Enjoy. Pay me 40 cents every month. So we got that. I said, fine. We got the name servers, but now the world doesn't know about the existence of this domain. So we need to tell the world, which is this, this is what the world knows right now, that you know what? Hello exists. So please listen to hello. And how do you do that? You put in here name server entries in the DNS, NS, 4 entries, 1, 2, 3, 4. These 4 entries go in here, correspond to this subdomain. And in those 4 entries, 1, 2, 3, 4, you put brother 1, brother 2, brother 3, brother 4. Those 4 entries that these guys gave us, that's what you put here in Cloudflare. And then suddenly the world knows that you exist. That's what I just did. And this, by the way, is the most complex part of the exercise. Understanding and clearly creating a wildcard DNS is the next step. Now that we have a record for this entity, and that we want to know where the DNS is so we can then figure out these B1, B2, B3, B4 that we have. Those are the DNS records, records for this subdomain. So now I want to actually go here into Google Cloud and edit that zone file for this zone, hello, and create a wildcard entry like hello.cloud.us. That's what I want to create, a wildcard entry, and I can do that in Google Cloud DNS. Or you can do it in Amazon AWS Route 53. AWS Route 53. They're very, very similar tools. Both are nice. Use them or use them, doesn't matter. Don't go free, by the way. Do not. And I'll tell you what happens if you go free. Certain features may not work and you will have trouble doing the exercise and you will miss out the fun. So I don't want you to miss the fun. Spend some few cents and get a proper DNS. And you can kill it off later on after the exercise. So a couple days and you're done. So we want to create a wildcard DNS right now, which is what we will do, create a new record set. And here we will put the wildcard asterisk right there, this wildcard. I just did that. Then I will add 3 items, IP addresses, A records, 3 items, 1, 2, 3. What do you think we'll put here? We will put what DigitalOcean gave us, right here. Individual A records are to be created for the hello.cloudgenie.us should have A record entries for each machine's IP address. We have these 3 machines IP addresses, 1, 2, and 3. That is what I want to take and put in these 3 boxes, 1, 2, and 3. That's what you see in the picture here for Google Cloud DNS for the wildcard entry. So wildcard entry, like here, and 3 IP addresses, 1, 2, and 3, 1, 2, and 3. So I'll go grab them from here, grab the 3 IP addresses, copy them, and then bring back to our notepad. Where is the notepad? Here. And so I want to have these 3 IP addresses, 1, 2, and 3. So I will then make some room, proper room for them, like this, 1, 2, and 3. So those 3 IP addresses need to go as A records in the wildcard entry. I will take one of them, put it here. Take the other one, put it here. Take the third one, put it here. And those are 3 entries for the 3 machines that we have as a wildcard entry in the new TLD hello, which we just created. And then we create this wildcard DNS entry like this, create. And now we are done. We're done with the DNS part. Let's keep going. So we now have the record for hello.cloudgenie.us look like this in the picture here, which is what you see in the zone. In the zone here, you will see that there is a name server entry for these B1, B2, B3, B4, and there is a wildcard entry with 3 IP addresses for an A record. That's what we wanted. That's what we have as shown in this diagram, in the picture, as well as in the real example here. Okay, now we want to validate the DNS before proceeding forward. We want to actually connect to these boxes and make sure that the connection works, make sure that the DNS actually is valid. And let us attempt these 3 lines one at a time. And so we will copy that one at a time, and we will clear up some room and paste. 1, do you want to connect to the machine? Do you want to connect to the first box? This is the first IP address. It's called days number 1. And we will say yes. It's fine, it succeeded. And the days number 1 succeeded. Now we'll run the other examples. So second, okay, copy and bring it here. Number 2, we say yes. Yes. And it succeeds. I'm going to mute a couple of folks. There we go. So then the third one, copy, bring it here, paste, enter. It's going to connect to all these 3 boxes one at a time, and you will notice that this wildcard entry has taken shape of days number 3. This wildcard entry has taken shape of days number 2. And this wildcard entry has taken shape of days number 1. Let us compare. Days 1, IP address is 238.103. Days 1, the IP address is different. But over, is it the same IP address? I think it is reaching the same IP address. So only one of these guys actually is connecting as the endpoint, but the MAC address, okay, so it's using only one interface to connect to these 3 machines right now. Next up, we'll check whether Days control software is already installed by running this command and testing for the existence of that software. I think it is already installed, but we'll just quickly check whether that software is installed already. So we'll go paste the command, not this, cancel, not that, but this command. We want to copy from here and check whether Days is installed. So I am going to grab that, paste it, and we'll check the version installed, and it is there. It is matching the same version that I checked out. You remember my Git checkout was 1.12.2. And so Days control actually matches the same version that we have locally installed, which is also 1.12.2. And that's the Days control software, which is locally installed for the machine to operate. Next one, what we are doing is, if it is not installed, if the Days control is not installed, this is how you install it. But I think it is installed already, so you don't have to worry about these steps. No need to do it. You can skip. So this is how you actually install that piece of software. So you can skip that part. Next up, we want to enable keyless login. So we don't have to type this key over and over. We don't have to type the -i and then /tilde.ssh/days. We don't want to type these. Excuse me. We do not want to type those commands over and over and over again. So there is a little software. It is called SSH agent, and that will remember our key. So we want to execute those commands to make it remember that we are going to use that key. And then we add that in the SSH command, SSH add. So it remembers this identity that I want to keep using. And then we establish a tunnel. A tunnel is basically a place for us to enter. So we will enter through that door into our cluster, and the tunnel gets established through this export line. And then we will list what do we have. So right now we are in the Days folder, which is where we need to be in this folder as all along. That's the folder we need to work on. And then we are exporting this line into the shell, and then Days CTL, and then we try to list out what do we have. You will see that it is going to go connect and find out that it does not have any load running. So the unit, machine, load, active, and sub, these are entries that you expect to see once you have some load. But right now we don't have any load. So it came out with blank result. That is expected. We will see that the result should be like this, and which is what we saw. Now is time for us to install that platform as a service. To install that platform and start that platform, we have to do these steps one at a time. So we have to first step, configure the platform to use this private key that we have here. So that's the line here we are going to run. Configure the platform to set my private key, this one. So it is going to tell the platform to use this private key that I have, which is what is pasted here. So it is correctly set. Next up, I will tell my platform to use this domain that I made up, hello.cloudgenie.us. So I'll copy that line and paste. And this is how I'm telling my software, please use this hello.cloudgenie.us as opposed to herokuapp.com or something else. This is my platform as a service. So use this, my made up domain. And so I'm setting the domain. Next up, I will install the platform, which should be quick. The platform get installed from the Days folder, which we are currently sitting on. That's where the software is. This software is going to be installed on the remote platform on those 3 boxes we have in DigitalOcean. That is what you're looking at right now. These 3 boxes that are currently running live are getting loaded with the Days application itself. And then the next step will be to start that platform. And that platform, to start it, takes about 15 minutes. And this is through past experience. To start the platform, we have to run this command, which is to start the platform as a service that we have installed. So we succeeded with the installation step. Now we need to run and start the platform to boot up Days. So in here, it will actually use this entire software that you're looking at on GitHub and run it on those 3 boxes on our own infrastructure. When we hit start, it will take about 15 minutes, as I expect, on these 3 boxes so it is running remotely, by the way. So it is not running here. It is running on those remote boxes on these 3 droplets based on the usage of this piece of software. It remotely executes and it starts and does things that is expected to do as we go along. And once this, in the next 15 minutes or so, we should have a platform as a service ready and running and started, which means we will have our own Heroku, our own Red Hat OpenShift, our own Engine Yard, our own platform, but running this software, this Days software. That's what we are looking at. And that's what is actually installing. It takes time. So you have to be patient to let it finish and not disturb it. So I will minimize this window. I'll just leave it alone, not touch it. And then once that thing starts, the Days platform, you can then list. And you will see all the services running inside and what services are active, loaded, and all that. You will see a result like that. And then you can check the other thing, which is a tool called Days as opposed to Days controller. So this tool was Days CTL. It's the controller tool, which is controlling the platform itself. Whereas this other tool that we will be using after the platform starts and up and running is like your Heroku command. So Days version. And then we will have a thing to do like Days keys add, or git clone, or git remote, and then Days master, push Days master, Days open, Days scale, scale it to 3, and then you open, then you scale it to 13, and that's not a limit. Just go any number it can handle. It's a fairly big cluster, the 3 big boxes, so it can handle no problem. You can scale more if you like. And you can see that your application is actually scaling comfortably across multiple containers inside your platform. And you can scale it down if you like, and then keep examining how the thing actually works. And then when you're done scaling out, scaling back in, and playing with it, and pushing your apps, deploying your apps on that platform, like create and then push, and create and push. And those things, here is a sample app that I will have that you will take and then create and deploy, and create and modify and deploy and scale. Once you're done with this, then you want to destroy the whole thing. And so here is a destruction step. And so you can destroy the whole platform. And that's what will conclude that exercise. But we will get to the starting first. So we're waiting for this to start. When the thing starts correctly, we will then play with it just like we played with Heroku. So that's the flow we will want to do in the next few minutes. As soon as this thing finishes, we'll be able to play with it. So we'll leave it running, and we'll discuss something else, such as what is going on right now. Give me a second, I'll just grab a water and talk in half a second. Hold on. Okay. So what we have under the covers, we have those 3 boxes, right? Box number 1, box number 2, box number 3. We call them Days 1 days, 2 days, 3. These boxes know about each other. They know about each other because of a service, etcd.io. So let's go etcd, etcd.io. It's a discovery service from this company called CoreOS. CoreOS is another implementation of Linux meant primarily for containers. It is so tiny and so efficient that it is becoming the most popular platform for running Docker. It has become that platform. It is smallest, really, the philosophy is just the bare minimum that you can get away with, the commonality that is needed to make container infrastructure work, the bare minimum kernel needed to make it so that any Linux distribution can work on top. That's what CoreOS actually does. It is not your desktop operating system like Ubuntu is, for example. Ubuntu is also a server version, but this is your Ubuntu desktop that you're looking at. So it gives you a full-fledged user interface and all that, and applications and everything else. But CoreOS is not like that. It is just a, what I call, just enough operating system. You pronounce it like juice. The idea behind juice is like this, that when you begin with installing something, you want to go as little as possible as you can. So when you buy a Dell laptop running Windows, what do you get? What do you really get from a software perspective? Do you know? Are you getting just Windows? No. You get Windows, yes, but you get a ton of what I call, the technical word for it is crap. You get a ton of crap that Dell wants to use. Dell wants you to use. So they just load that crap on the laptop and sell it to you. That is not Windows. That's a Windows plus crap. You want to remove that crap. And it is very hard to remove it for a common mainstream user. And Dell loves it, that they are able to load this piece of trash on your laptop, because they make money of it, about $50 roughly. And I know this from my first-hand experience. They make money by adding third-party software on your laptop, which you don't want. And so you should actually spend, there is a way you can spend a crap-less machine by paying extra. And this is a fact of life. You can go to Dell and say, you know what, I'll give you more money. Please do not install that piece of crap that you install. I'll pay you more money. And they have a program for that. That's the craziness. Most people don't use it, but that is the unfortunate thing that you run into when you buy commercial machines. When you're getting Windows, they give you other things that you don't want. And that hurts. That gives you, sometimes give you, some toolbars from Google. Sometimes they will install some browsers that you don't want, and some other application that will monitor you, and all crazy things happen. The bottom line is, as little as you add onto a piece of hardware, the better it works, because your applications are not competing for resources from the underlying hardware. You add more stuff, it competes for resource. You don't want them. So the core idea is do as little as possible as you can. And that is what is just enough operating system is. In fact, you don't even want all these things such as, you have a ton of things here, right? In this machine, you have a bunch of applications loaded, even in this virtual machine. So I have loaded a couple of things which are not required, like this solitaire application. You don't need it. Amazon, Archive Manager. You don't need these things, but they just exist because Ubuntu gets paid by Amazon to install the Amazon applet and I forgot to remove it. So it is there. So you can actually click on it and it will open up Amazon, but you don't want it. Why do you want Amazon on a Ubuntu machine that you are using for study? I don't think so, but we have it. And so Ubuntu got paid out of this, by the way, out of the fact that I opened this instance. Ubuntu probably got paid a cent or something. And that's the problem. The problem is not that they're getting money. The problem is that it is competing for resource on my machine. So I don't want unnecessary software like calculator and Clementine. I don't even know what these things are, but they just exist. And it's unfortunate in that if I want to have a nice, agile, nimble infrastructure for my applications, I want to know exactly what I am getting. So I want to know exactly what pieces of the operating system am I getting, and nothing more, no more, just the operating system. And what does that boil down to? So say, for example, if you want to run that same example, we have WordPress, and you need LAMP stack, Linux, Apache, MySQL, and PHP. What if I say that I want to give you Python also? Would you take it? It doesn't hurt. Install Ruby also. Would you take it? It doesn't hurt. Do you want this thing here at all? I don't think so. Why do you want Python and Ruby when you don't even need it to run WordPress? You don't want them to be occupying your hard disk space. So your SSD or HDD will be occupied by this installation. You don't want that. Even if you're not running it, it's still occupying your resource. So cut it. That's the scenario behind Just Enough OS. So you want to really be very, very particular as you build your images up all the way. And I'm not talking about virtual machine images, although that concept also applies to VMs. I'm talking about Docker images. As you build images, which you will, by the way, you will have to very disciplined way of adding what you want to build on top of an image that will be your image. And you want to be very disciplined about what you add in the layers underneath. So for example, here, I want to have a basic Linux, and I can choose Debian if I like. And I'll choose Apache, MySQL, PHP, and boom. And I will make sure to not have anything else, like absolutely not. And that's the kind of thinking, because it translates to very small, lightweight images. And that's what this open source product called CoreOS also helps. They have these services such as etcd for consensus and discovery. They have a competing product to Docker called Rocket. This is a container engine just like Docker. And they have other tools that you can eventually use if you go there. And there are more. There are 90 more products like that, all of them open source. And so that's what we used in this example of etcd to have machines discover each other. And these 3 machines that we have right now, which are running here, are actually CoreOS. So if you go look at them, they are CoreOS. See that? Right there. And so it is running CoreOS as the operating system underneath. And that is a choice available to us. If you are creating a droplet, you can see that you can choose CoreOS. So instead of Ubuntu, you can go here and select CoreOS and select stable. And there we go. That's how you would select. And we chose that through our Terraform deployment. You remember we ran Terraform by a command line to install those 3 boxes and created a cluster out of it. And we used Terraform, and that in turn used CoreOS as the operating system for these 3 boxes as you are looking at. It has been running since 1940, and right now it is 1955, which means it is about to finish. So we'll be patient and not kill, not disturb, but I know it is time. So it should be finishing up pretty soon. We'll wait for it to happen. We'll, in the meanwhile, monitor some performance as to what these boxes are doing. So we'll go there. And there is a chat question here. Hold on, let me see what that is. Yes, the question is this like using service registry? Conceptually, yes. Yes. It is about discovery when you're using etcd. And in these machines that you're looking at, these three boxes, let us see what they are currently doing from a bandwidth perspective. From a CPU consumption perspective, they seem to be busy doing stuff. Disk activity is low, but CPU activity is going on. You can see that CPU is actually active up to about 11-12% for the last, ever since it started. It is started at 11:19 p.m. and right now it is 11:53. But the actual invocation happened at 11:42. The install and start the platform happened at 11:42, so it does not have enough times elapsed. That's what you're looking at in this chart, which is indicator of the performance of the box that are being busy running your those three machines that you're looking at. Let's see other machines, what they are doing. So we look at the droplets and look at days number 2, look at its performance, and here it comes. We see that the CPU consumption is still non-zero. It's doing stuff, and there is some traffic. It also started at 11:43 right now. There we go. And let's look at the third box, which is the droplet number 3 here. And here we have similar story. The CPU consumption is still non-zero. We have about 6% CPU consumption. So it is busy doing stuff, which is basically getting the whole thing started. And we should wait for that. And I am very impatient by nature. And so when it doesn't respond to me right away, I get impatient, but I know from experience that it takes time and we have to wait for it. So let's talk something else. Like, what do you have in mind? Or if you have any questions.
So Nilesh, this is Salam.
Yeah, hi.
Hi. So for this deployment, we don't need Zen server or something like that, right?
Did you say Zen server?
Yeah.
No.
No. I'm just
Correct. We are not using any hypervisor.
Any hardware. Okay.
No.
Yeah.
We are using
Docker. So this is the Docker container.
Salam, when you speak or when you are active in microphone, somehow you create a lot of noise. Looks like you're touching the microphone with a paper, pencil, or something like that.
Oh, okay.
You touch something somewhere. You touch the microphone. That's what it sounds like.
Yeah, because when I talk without microphone, there's this happen. Okay, I got it. Thanks.
Yeah, but you're still noisy. So the noise comes from the fact that you are touching the microphone in your laptop or your cable. That you
No, I have a fan running on that side, maybe.
Okay. Some wind is blowing on the mic. That's what's causing a lot of noise when you speak.
Okay.
There again. We just had it again, but no worries. Keep going. Yeah, this wait game is hard, but we have to wait for it. So
Okay, how about now?
yeah, still noisy, man. Still noisy.
Because of fan, maybe.
Yeah,
All right.
possibly. Yeah, I know.
Sorry about that. Okay.
No worries. So I think I want to keep it running. I know if you have to go, it is okay for you to just leave. It is 8 o'clock. I will keep the session active and wait for this thing to finish. When it finishes, I will keep recording. And if you want to stay online, you're welcome. If you want to drop off, that is totally understood. But if you can be online, we can actually do the, I intend to do the whole thing. Like I'll follow along as it finishes. I will actually deploy apps just like you did on Heroku. I will do it on our own pass. And I'll do those things as we go along. And then I will create a recording and then pass it on to you. If you want to stay, you are welcome. If you want to go, I understand. You will get a recording, by the way. So this particular session actually is the last session of the series of cloud technologies, which means I need to assign some reading homework for you guys. So I would like you to read a book. It's a very small book. It's easily available in public library. The book is called The Goal. And that is the book I would like you to read for the next upcoming series. So the book is called Goal. It is available on Amazon, on Kindle, on library, in public library. And if you are, I saw something here, Google Play, it's $2.99. So that's the best one. That's the best price I can find. It's right there. So this is the cheapest iteration of the book that I have seen up until date, $2.99. The Goal, Process of Ongoing Improvement by Eliyahu Goldratt and Jeff Cox. It's one of the best books that you can read, as according to, I'm not saying this, I'm asking Jeff Bezos. 3 best books. Let's see what Jeff says. So Jeff says, I want you to read 3 books. And those books are The Effective Author Executive, the Peter Drucker, The Innovator's Dilemma by Clayton Christensen, and The Goal. The Goal is very different from the other 2. It is not a classic business book, but it's a novel about a manager, about operations. So that's where the concept that I want to talk about is DevOps, which is, it's a classic book on operations. It has nothing at all to do with computers, by the way. So you will see that this concept of DevOps actually originates from manufacturing. There's lots of things about it. You can roll. I'll be opening up access for you guys here in the DevOps section, which also has a ton of material for you to read. And so there is a Goal book. There's a book summary available. There is another book to read, but these are optional readings. The real required reading I would like you to have is this summary, the book summary, which is already available here. And I will open up access momentarily. But this is what I would like you to read. And it is available already here. You don't even have to buy the book. But if you are inclined, so you should get that book for $2.99. I think it is an audio book, if I remember right. Yeah, it's an audio book. So you can click the buy button and get the book and all that. No, hold on. This is not the book. This is the key takeaway and analysis of the book, not the original book. Oh, hold on. Not this. Don't get this. This is not the book. It is key takeaways and analysis. Nah, not this. Get the Goal book is right here. Or just read here on the site. You will be able to read that. So just read this one long page, and it's a summary of the book, which will help you understand what I'm talking about. There are a few more things to review, which is also another slide share from the author himself, or the author of the book, the Goldratt Institute. They have a slide share. You should read that. And we'll talk more about when we discuss this new thing, the DevOps program that starts when we start on 22nd. Is that right? I think so. Yeah, so 22nd, we start discussing this core concept. We'll build on it. There are tons and tons of exercises coming along your way. So make sure to finish this technologies exercises as quickly as you can, because in here you will have more, and you will probably get tired of doing exercises. I suspect that if that happens, tell me. If you find that the exercises are too trivial, tell me. Too intense, also tell me. And so we'll adjust, we'll tweak depending on how your digestion level or comfort level with amount of work you want to do. But the core idea is I want you to really get DevOps, and we'll do that along as we start. I'll open up access momentarily after I finish recording. Any questions on the book aspect or the goal book? I'll also post a link for you to read so you know what to read. I'll post a link to the summary, and you cannot access it right now, but by late evening, I will open it up. So you should be able to read this summary as soon as I open, and the link goes right here. There is a question from Srinivas says, need help with the Heroku example, and you are welcome to ask that question, sir. Srinivas. Hey, are you there? Okay, I will unmute you. Hold on, I'll unmute everybody. And go ahead, Srinivas.
Oh, okay. Yeah. So mine is a basic question. So I'm trying to follow the Heroku steps, and I have this generating the Rails generator. Controller. In the model view controller example, Rails generate controller welcome page, right? So having probably the syntax. Oh, can you hear me?
Yeah, you can project.
Oh, can you hear me, Nilesh?
Yes.
Hello?
Yes, I can. And I would like you to project your screen. Please project.
Yeah. Right. Yeah, sure. Let me do that. I will do that now. Where is that? It used to be there in the Zoom, right?
Yeah, it is in Zoom. It should be share your screen button.
Back to meeting. Where
It
is
should
the
be
share?
green.
Yeah, I know it was there, but
Bottom, there is a green colored button.
right. It was there. Oh, am I not in the meeting by any chance?
You are in the meeting. You're talking to me.
No, not in the phone. Okay, you mean I think both are integrated. Okay.
Okay.
Somehow I'm not seeing the Zoom. I mean, somehow. Oh, okay. I think I kind of know. Okay. 1 second. Okay, got it now. Okay. So where am I? Oh, are you able to see my desktop?
Yes, I am. I'm able to see it.
Oh,
and
yeah. So I'm at the very beginning step. So where I think it's a syntax thing. So
yeah, let's figure it
if you
out.
see Rails generate controller welcome.
Don't run it here. Don't run it here. You're in the wrong folder. You're in the wrong folder. You need to be in the you need to be in the My Apps folder.
Oh, I see. I think I missed that part. I see.
Yeah, keep going. It should work. No problem.
Okay, sure. I think it must be okay. Probably I missed something there. Yeah, okay. Probably there is a instruction to go into. Okay, sure. Yeah, great. Thanks, Nilesh. Thank you.
Shop now at